statistics vary, and basically the other way around as well, vice versa, right? So there's chronic fiscal imbalance in wealth, and the last thing is critical systems failure. So what that essentially means is like you've got the written like cyber terrorism, cyber attacks. So we live in a really fragile society. You know, one of the examples is HSBC Bank. It only took HSBC Bank to go offline for a few minutes, and tons of transactions went go through. People started panicking. I remember I was buying some trainers last year, and I put my credit card in, and they kept getting declined, right? And the reason was because the bank went offline. But that was just me buying trainers. It wasn't people paying mortgages, paying student loans, and etc., etc., etc. So there is a real problem with the systems that we have in place. They're really fragile, although they're good. Right, so the key thing that BREC is not trying to solve the world's problems, right? We're trying to solve two challenges. One thing is the rise in greenhouse gas emissions. The other thing is the chronic labour market. So basically, essentially you've got unemployment, right? You've got an increasing rate of unemployment. So two things that BREC are trying to do is tackle the greenhouse gas emissions and then help people create startups to create businesses that will create more jobs, right? So in summary, that's what BREC is trying to do. One thing, so you guys are smart guys, right? You're chemical engineers. I tried to explain this concept to PhD students and they struggle, right? So I'm going to get you guys, I'm going to ask you for a bit of help. Can someone do like a mass balance of emissions? So these are the emissions, right? Carbon emissions over 1750 till 2010. Right? Can someone do a mass balance of the emissions qualitatively, not quantitatively, for that time frame? Sorry?
Do you want to do
Just qualitative, just describe what, according to that, what's happening.
it includes like marketing.
Right, okay. So in terms of in and out, what do they represent?
You see, in represents the year 1750, and then the out is 2010.
Right. Let me help you out a bit. So basically, if you think about CO2 emissions, if you do a mass balance specifically based on CO2 emissions, right? We don't have, as far as I know anyway, we don't have CO2 emissions leaving the Earth, right? And you don't have emissions coming into the Earth, right? So that means those, you can sort of cancel those out. The next two terms are generation and consumption, right? What's generating, so if you look at this, if you look up to 1890, there is an increase, but it's not a dramatic increase. After that, you'll notice a blue line, which is coal, which says solids, but solids refer to coal, right? Liquids refer to oil, and gas is natural gas. As soon as you had coal usage, you see the black line increase, okay? And then later on, you see the yellow line increase, which is oil consumption usage, and the blue and the yellow line cause a dramatic increase in the overall total emissions, okay? So your generation in emissions, and this is something that's chemical engineers, most of you will go into industry, right? This is important you understand this. This is something that I got from Professor Mike Bauman, who's worked for BP for 30 years at last year's Energy Manchester Summer School. And he said if you're going to reduce emissions in industry, you need to focus on two things. You need to look to reduce coal usage, consumption to produce energy, and you need to look to reduce oil consumption. You need to look to go towards gas, right? Natural gas. And that's the interesting thing about shale gas, right? So the movement, if you're going to tackle the emissions problem, you need to sort of divest from coal and oil towards gas, okay? But anyway, long story short, what's the consumption? What's consuming emissions? Sorry? Yeah. Plants, right? Okay. So one of the latest things. How many of you know a guy called Elon Musk? Tesla Motors, right? But yeah, no, good. At least some people know. PhDs are clueless. But anyway, so Elon Musk is trying to initiate. So this is a guy who's a billionaire. He's trying to send rockets to Mars, and he's come up with Tesla Motors, and he's trying to initiate an electric economy, right? A renewable electric economy. That's what he's trying to initiate. Now here's the thing, and this is important as well, you guys need to understand this. So if you were to electrify everything, right? Electrify, so if all the cars went electric today in the UK, do you think it would reduce emissions?
Not necessarily.
Exactly, right? And this is the problem with consumers. A lot of people are buying electric cars at the moment thinking, okay, we're going eco-friendly. But here's the thing, if by electrifying all the cars, you need much more electricity. If that source of electricity is upstream is from coal, right? So you're going from oil to coal, you're just gonna have more emissions. You're not solving, just because there's no emissions downstream at your car level, that doesn't mean that there aren't no emissions upstream, okay? So the next part is he's trying to aim for a renewable electric economy, right? So his vision is to create these solar cities that will generate renewable energy, and then you electrify the cars. So then you've got clean upstream, and then clean downstream, okay? Again, what's the limitations to that?
The sun.
Yeah, the sun, but also, more specifically, solar photovoltaics, right? They're not quiet. Can we produce that much energy from clean sources? Okay. Now, I'm going to so we discussed this at Energy Summer School as well with the PhD students that, say, for instance, hypothetically, we had nuclear reactors all over the world that could produce mega amounts of energy, right? And also we had we electrified everything, right? So there's no emissions upstream and downstream, right? There's still a limitation, and this is the limitation of Elon Musk. And I'm in Manchester, he's in California, he's a billionaire, I'm a PhD, right? Trying to do this in the bioeconomy. But here's the key thing. Key thing is the limitation to a renewable electric economy is that you still can't generate clothes, for example, right? And even if we went neutral, your consumption will not decrease, which what chemical engineers understand, and you guys understand from mass balance and other people don't, is that we've got accumulation of emissions over a century. In order to restore balance, you need to be not only reducing the generation of emissions, you need to somehow increase the consumption of emissions. Does that make sense? Right? The only way to do that, so some people are proposing carbon capture, right? But from my point of view, pragmatically, it's plant more plants, right? And that's where bioeconomy comes in, and I want to tell you a bit about bioeconomy. So at the moment, this is a map of the entire chemical industry, right? Virtually an entire chemical industry. It can be summarized in four things, four raw materials: oil, petroleum, natural gas, O2, N2, and SO2. From that, you get all these intermediates, right? From that, you get all your finished products and consumer goods. So virtually everything in this room, you know, textiles, food stuff, transportation, housing, recreational stuff, communications, health and hygiene, everything can be traced back to petroleum, natural gas, O2, N2, and SO2, right? And so what is Professor Webb has tried to do, and what other people in the bio area are trying to do, is trying to replace the petroleum, natural gas with biosources, right? If you can find biosources and then create intermediates and then create products, you create what is known as a bioeconomy, right? So what we live in at the moment is a petrol-based economy, petrochemical economy, right? And so the movement of bioeconomy, and this is something that's picking up really quickly. I was in Brussels last month, and there's a big movement in Italy. There's a professor there at University of Tuscany, and this actually originated, the concept that I first learned this from was in US, right? And I'll tell you more about this. But anyway, that's the concept behind bioeconomy. So this is something this might be of interest to people that are from non-oil producing nations, non-OPEC countries. As an example, in 2004, National Renewable Energy Labs did some research. So one of the things that Breck, and we have a spin-off as well now that we're trying to develop a consultancy. One of the things that we're looking at with the latest technology is doing drone scanning, right? So you can go to any country in the world, right? Use a drone to scan the land and work out what biosources it has, how much edible, what is the soil condition, how much edible crops crops it has, how much waste crops it has, how much non-edible crops there are, and then based on that we can see how much like oil we can get, how much starch there is, how much carbohydrates there are, and then what products we can create. And so this is something that's happening in the US. So basically in 2004, these are the things that the US were talking about. They're saying the US is the Saudi Arabia of carbohydrates, right? They were saying that, and those things that they were saying were moving from an economy based on geology to biology. Right, so this is a movement that is picking up rapidly, and the drivers, like I mentioned in my first slide, are rising greenhouse gas emissions. So one example of this, so in 2003 there was a collaboration between DuPont and National Renewable Energy Labs, and essentially this is what they said. They did a partnership, and the aim was to design like a corn biorefinery. So it was to develop a design package for farmers to produce fuels, chemicals, power from entire compounds. Right? So all you do is get some corn, right? This could be, I think it was in South America where they initiated this. But you get the corn, and using just corn, you can produce chemicals to produce biopolymers that can then produce jackets and all the other biostuff, right? Also bioethanol, so you can then use bioethanol to power cars. But not only that, you could use it for power, right? Now the biggest critics that I have since I started this, and usually it's people that aren't familiar with bioarea. So one thing that people say to me is, Adeel, it's corn. How can we do that? It's going to fluctuate the food prices, right? This is the thing.